we're doing today, because I've had some folks ask about it, and plus I've seen some folks who are trying to do TDD, but are coming from a place where they're novices, and it's great to see people try it out. But I really wanted to, I'm always doing TDD, almost always, except when I'm specifically not doing TDD, like I did with the blackjack game. But normally I am doing TDD, but sometimes it can be hard to see what's going on or why I'm doing things or what the particulars are about TDD. And since I'm also our book study group on the TDD by Example by Kent Beck, our first official Zoom meeting is actually a week from today. I figured it was good timing to sort of see what we can do in a couple of hours, basically doing TDD from scratch. Oh, hey, Offie. And Simon Gearing may or may not be eating all the mini chocolate Swiss rolls while waiting for the stream to start. Well, I hope he left some for other people. All right. So the first step, let's switch to our code. Let's actually switch to here for a second. Okay. So you're probably familiar with, if you've heard anything or you've read anything about TDD, you've probably can't get away from this cycle. You've probably seen this, right? The red-green-refactor cycle. Sometimes people use gold or yellowish for the refactor. I like blue. But, you know, the color of this one doesn't matter as much as sort of the red-green refactor, right? So the idea is, the simple version, the simplified version is you write a test, it fails, you make it pass, then you refactor, and you keep going. And so if we dig into this a bit, we might say, well, why are we doing this, right? So for me, when I'm trying to decide whether I'm going to do code first or test first, right? Am I doing test first or test-driven development, or am I just going to, write some code? And there are times when I find I don't really want or need to write tests. Things like if I'm just creating a proof of concept, or I'm learning how to use some API library or service or something like that. Or if I'm creating a prototype where I know that I will destroy the code and then rewrite it properly using TDD, those kinds of things are the reason why I might use code first. Oh, thanks for the hydrate. I'm gonna hydrate with. Well prepped. I got my water and my caffeine. The reason why I like test-driven development, and so there are two kinds of test-first development. So what test-first means to me is basically I'm writing the test first, right? I mean, kind of obvious by the name. And what that gets us is, first of all, you can't forget about tests. And it's not like anybody really forgets about tests. It's just when your code is done, and I know, early in my career, when the code was done, I was like, cool, let's ship it, right? I'm done. Except you have no tests. And so once it's done, once the coding is done, the motivation to write tests is pretty low. I am no different than probably most of you who are like, I've already written the code. Do I have? All right, maybe I'll write one or two tests. Yeah, Simon Gearing, that's a very good point, and sure understanding of the problem. And I talk about that. And the idea is, if you write the tests first, then when the code's done, you've got tests. And so for me, a lot of it is actually about the motivation. I think most developers recognize that if they're not writing a lot of tests, if they're not writing enough tests, they should be writing more. They may not do it, and I totally get the motivation, the reasons why you wouldn't do it. Right? It's like it's working, so why should I write some tests? I often use, even when I'm learning an API, I'll do test first. So I want to talk about the TDD thinking because it addresses what Simon Gearing pointed out. Is there's there are two important questions, and it kind of amazes me that we're able to actually write a lot of code without being clear about the answer to this first question. Bob asks, where can you learn Scrum software tools? I don't know. Depends on what you mean by Scrum software tools. I don't generally use Scrum, but there are tools that support it, so I'm not sure. You'd have to be more specific. Hey, Mindful Fox, how's it going? So for TDD thinking, and this applies to test first or test driven, and we'll look at the difference between those two because it's subtle but important. And you won't always be able to do TDD. If you've got a legacy code base where tests run slow, or it's hard to access the objects that the classes that you want to test, you're not going to be able to do TDD. So the main difference for me when I talk about test first versus test driven is how small of a step can I take at each sort of step through the process. With TDD, I want to take the tiniest possible steps, and we'll see that when we actually start coding. But the two important questions are, and this is what Simon Gearing is talking about, is like, what do you want the code to do? Right? From the point of view of whatever the client of that code is, and being able to express it in a test. Right? It is amazing to me, because I've done it and I see people do it when I teach, that you can sit there and write code without having clarity about what it is the code should do. It's like you have some amorphous goal, and as you start writing the code, you start thinking of different edge cases and different options and different things that can happen, and all of a sudden you've written 50 lines of code with 3 levels of indentation of if and for loops. And we do this, and we do this a lot, and there's a lot of code like that. So figuring out what it is you're about to write some code, what it is you want it to do, is one of the most important questions to be crystal clear about. Then the next question is okay, you know what it's going to do. How do you know it did it? That can be the hard part. You may not be able to access properties or state or something that will help you figure out, did it do what I wanted? Right. So for example, if we're talking about a blackjack game with a deck, and the game starts and 2 cards are dealt to the player and 2 cards are dealt to the dealer. Right. So the startup is deal. Well, how do I know that worked? Well, if you don't have access to the player's hand, you're going to have to figure out some way to tell the cards got dealt to the player. So some questions in chat. Oh, hey, the goat. Are there still a lot of jobs in technology and engineering? Yes. All you got to do is look at Hacker News every month or look on the job sites. So yeah. Hey, Vivax. Yes, Simon Gearing. It is scary how much code we can write, and it will actually work. Right? That's the thing, is like, it's not like we're writing a bunch of code that ends up not working. A lot of the time it works, but we don't have a clear understanding of the problem, because we didn't think about what do we want this code to do. Right? And if we didn't figure that out, if we had some vague sense, which is usually what we go in when we're writing the code, that's what we go in with, right? Maybe we have a user story and we talked about it, but really being clear, I expect that when I do this, this happens. That's the fundamental piece that you need to do test first or test driven, right? And so does your validation, right? What assertion are you going to write? Does it require validation of a whole bunch of objects? And the more objects you've got, the harder it is to write good small tests. But a lot of times we don't have that choice, right? In legacy code, I have to, instantiate 5 different objects before I can test the one thing I'm interested in. Not the end of the world, but wouldn't it be easier if maybe you could get away with fewer pieces of code? So these are sort of the central things that I think of when I'm thinking about test-driven or test-first development. These 2 questions, not only being able to answer them clearly, but answering them precisely enough that you can write code that will actually assert that, right? i.e. a test. But hey, Vladimir, Zoom frozen does not refer to the movie. My bandwidth looks okay, so hopefully it's okay it was just a glitch. Simon Gearing says, or you build all the CRUD code because it feels like progress without getting to the difficult part of code. So your risk comes later in the project and bad things happen. Yeah. And you may find out you completely misinterpreted something. You've left out some edge cases that weren't so edgy. And you didn't find out until you basically had some other thing connect with your API if you're writing an API, and you find out, oh, there was something not right here. Or you made assumptions about some piece of code, and then when you finally run the whole thing, you realize, oh my God, that's just wrong. Or you may not notice it, and QA picks it up. Or even worse, customers pick it up. So that's the TDD thinking. If we go back to sort of just Red-Green-Refactor, this is sort of typically the coding sequence. So Mindful Fox, which TDD resources would I recommend? So now is a good chance to join the book study group if you can. If not, even if you can't join the Zoom calls that we'll be doing once a week, you can still join on the Discord. There'll be a private channel for discussion. So we're going to be going through Kent Beck's TDD by example book. Of the available books, that's probably one of the better ones. Offie, doing TDD having in mind these tiny steps, like thinking while developing instead of writing the possible solution on paper. Yeah, so what's interesting is that we shift the thinking part, right? So a lot of when we're writing code, hopefully we're thinking. Sometimes we're writing boilerplate and we're not really thinking. But when we're really thinking about how am I going to do this? How am I going to solve this problem or get this thing to work in this specific way? One of the things that I have found is that answering those questions, right, these questions up front, means I'm doing a lot of the hard thinking up front. I'm doing it before I've written any code. So once I've written the test, right, figuring out how to write this test is probably can be the hardest part of the entire cycle of development. But once you figure that out, you write the test, you make a compile, and it should fail as expected. And we'll go into another diagram that goes deeper into this. Bob, join the Zoom course, and it's totally free, by the way. Hop into my Discord, ping me, and I'll invite you in. Vivax just finished a course about unit testing in Python, so this is very interesting. Yeah, so this applies to any language. Even though I'll be doing it in Java, applies to any language. Some languages you don't have to worry about the compile step, although you may have to worry about linting steps, so similar things. But the overall sequence is exactly the same no matter what language you're working in. Simon Gearing says trouble is TD is a bit like going running. I didn't run my 5 miles. I ran my 4.25 miles. Feels great when you're doing it and after it's in place, but getting up early to go out in the dark when it's raining requires motivation. One of the things I find is like building any habit, and luckily it's not that painful at times, although it can seem that way. I actually find doing coding using TDD now much easier than trying to code without a test. I kind of get really anxious and really struggle these days to write code without a test, as you might have seen when I was working on the blackjack thing. And it's kind of funny because I watch a lot of other live coders and absolutely no judgment, that they're not really writing tests. I find it difficult like all that keeps running through my head is, how do you know that works? But that's how most people develop, right? We write the code, we've processed stuff in our head about all, we're sort of running the scenarios in our head, right? If I do this, if this parameter comes in this way, then I'm going to handle it this way, and then I expect this to happen, and I need to do this. In my opinion, you're already running a test in your head. Why not put it into code as a automated test, and then you can stop running it through your head? And so I find that I do a lot less sort of simulating in my head what the thing is going to do, because I just write a test that does it for me. It's not to say I don't do that at all, but that's kind of what's going through my head. So the real cycle that we do, and then we're going to jump into doing code, is this, right? So we've got our what should it do, and what is this tiny validation to tell us that we know it did it. Then we write tests for the code yet to be, right? So we're writing down the test, and sometimes we may not know even how we're going to set it up, but we know what we're going to assert against. Your brain is the best testing framework. Bravo to you, because my brain is a horrible testing framework. It'll have things pass and when they really don't work. And so after we write the test, it'll fail to compile, unless there are methods that already exist and the classes already exist, in which case we'll just need to write whatever code we need to get it to compile. We want to do that right away. We don't want to wait until later. We want to get it to compile as soon as possible, because that'll have us thinking about objects and methods that we need to create. So we'll see that. Then we can run the test because it now compiles. And again, this applies to languages where compiling is important, like Java. We predict how the test will fail. So this is something that some TDDers do and some don't, but I find it super useful. In fact, this is the core of my card game version of TDD. I turned it into a card game, and the prediction is a key component. So we'll see that predicting how the test will fail means that when it does fail, it fails in the predicted way. If it doesn't fail in the predicted way, that's not good. Right? There's sort of a good failure, which is it fails as predicted, but there's a not so good failure, which means, oh, I expected a null pointer exception and I got something else. And so this we'll see helps us write tests that we can rely on, tests that are doing what we want them to do. Then we write the least amount of code to pass and the least amount of code. And how much code you write here depends on how far you are on the spectrum towards TDD, very tiny baby steps, versus just test first, where you might have to take larger steps. Then you predict it will pass, and it should pass. And if it does, even though it's not on here, you would then go through a refactoring step. So that's kind of the basic predictive TDD cycle that I use. So let's go create a new project. And we'll create a Maven project. We'll use Java 14, because why not? I'm not going to create it from an archetype, because all the archetypes, because I have an archetype that's more recent, but I haven't deployed it yet. So we'll skip to that. Put this in JitterTed. And this is TDD Yacht. I'm not using the trademark term Yahtzee, but it's basically that's the game that we're gonna work with. So I've got this Maven file. Let's put the minimal stuff in that we need. Let's grab this. Actually, we probably don't need all that. Grab the dependencies. And let me grab from here. Actually, maybe we'll use JUnit 5. Let me grab this. Add that property in. We're at 14. We don't need this. And yeah, let's use Jane at 5. So we'll grab this dependency. And I seem to have lost the dependencies. Okay, in our platform version, oops. Oh, I added the strong file. I've got too many files open. Let me close one of them. That one's not right. Close that one. This is the one I want to delete. And include this. And take this out. Let's put this in as 5 dot. Oh, that's the platform runner. I don't think I need that. You know what? Let's stick with Java 4, JUnit 4. So I should have done this earlier. Thought I had it set up. Okay, so we've got JUnit, and we've got a cert J. We don't need anything else. Let's add our that. All right. So the first thing we want to do, I don't know why this got called untitled, where I gave it a name. Let's go fix that. That's going to annoy me. Let's re-import the Maven file. Okay, so we're Java level 14. We've got our source files set up for Java 14. Okay, so we're all good there. I don't know how the project name got messed up, but I'm not going to worry about that. Okay, so the first thing we want to do is make sure, since this is a new project, is we want to make sure that our JUnit stuff is working. Now I'm using JUnit 4. JUnit 5 for the stuff we're going to do is exactly the same. So there's really no difference. One thing we're doing is instead of using the JUnit assert stuff, we're actually using a library that I use that I use a lot, pretty much all the time, called assert J. And so we'll see assert J has much nicer assertion mechanisms. I'm a bit biased because I'm a contributor, but it's actually become very popular. It's used in the Spring framework, so definitely much better than the assert equals core stuff or the Hamcrest stuff. So let's write a test. Let's create a new Java class. Put this in com jitter ted yacht test. All right, and then what we want to do is just should pass. So we're just seeing if basically did we set things up correctly. So we'll do assert that basically true is false. Now this should fail, obviously, because last time I checked, true does not equal false. But this is basically making sure that a clearly failing test should fail. So let's run it. And so it fails as expected. So therefore everything is good. Everything is set up correctly. So now we can change this to true. And now if we run it, we expect it to pass. And it does. So this tells us that our test stuff is set up correctly, and we can go ahead and delete this test. So there are times when you have tests that are temporary, like this one, where you're sort of maybe validating something, or you need it as a step towards something else. All right, so we've got our project set up, let's go take a look at the rules for Yacht. So Yacht is the generic term for Yahtzee, which is basically a dice rolling game, sort of like poker dice. And so the idea is you get 5 dice and you roll them, and then you score them in a specific way. Now, what we can do is we have a decision to make here, and this is where we get into what's called outside in versus inside out development. So you could say, well, okay, so we want to be able to roll 5 dice and see the individual dice. So we could start thinking about what would that look like. The other, and so that would be sort of outside in, right? Thinking about how do we use it from the outside. What does it look like to actually, if we ran it and it was working. The other way is inside out, saying, well, look, we know we need this concept of a die, right? A single die that gets rolled. Your standard 6-sided die, and we could basically start inside out, start sort of bottom up, and say, let's implement a die. We're going to go sort of outside in, and because that's my preference. There are different schools of thought on that, and sometimes it's not a strict thing. Sometimes you'll start outside in, and then you'll realize you need some more stuff inside, and you'll do more sort of inside testing, and then you'll basically go back out and you'll sort of cycle up and down these layers. So let's there's another. So the way the game starts is you basically roll all the dice, and then after rolling it, you can score the roll. So the idea is if you rolled all 5s, then you would score that under 5. I think the Wikipedia. Let's see. Not that kind of yacht. That kind of yacht. So this diagram makes it a bit more clear how the scoring works, right? So you start out with basically a sheet that has these categories here on the left, 1s, 2s, 3s, 4, 5, 6s, and then you get into sort of poker type things. And the idea is you roll the dice. You have some opportunities to re-roll some of them, sort of like discarding and drawing new cards, and then you decide which category you're going to put it in. So if I rolled 1, 2, 3, 4, 5. Then I have a choice of which category to put it in. And if I put it in the 5s, then I basically count how many 5s there were. So if I rolled 1, 2, 3, 4, 5, the number of dice with 5 on it is 1, and so the sum of that is basically 5, and that's my score. I could put it in the 1s category, and then 1, 2, 3, 4, 5, the number of dice with 1 in it would be 1, and that would be my score. Now, 1, 2, 3, 4, 5 would be a sucky one to put in these categories. You probably want to put it in a straight, and then you get a much higher score. Right, so the idea is you look at the dice and you see, well, which category would give me the most points. Problem is, if you've already used that category, you can't use it again. So there's a bit of strategy there. But we have to figure out what is the first thing we want to do. And I think the first thing we want to do is simply roll 5 dice and see the output. So that's what we want it to do. We want to be able to say, basically roll, and then be able to see the results of that roll. Now, if we were writing this without tests first, we might start writing a method that basically does a for loop and then does a system out println of the dice. And then we'd say, great, now we've got 5 dice rolled, and we can see what they're rolled. But now we've immediately coupled ourselves to system out, and that's kind of bad from a testing standpoint. So the advantage of starting with the tests then is it'll definitely make it testable. We're not going to gherkin. So gherkin, for those who don't know, is basically a way of expressing behavior-driven development, and then using a certain syntax to tie it to code. I generally don't use gherkin unless I'm writing sort of more complex or either much more complex sort of domain business kinds of things, or I know I'm going to want to sort of get a lot of leverage of reusing that kind of thing. So we're going to start with, well, so we want to roll 5 dice. And we could say, well, let's immediately, drop to rolling a single die. But let's see what happens if we go this way. So we want to figure out what is it we want to do. We want to say, when we say roll dice on something, we basically get 5 values back. So how do we want to express those 5 values? Simple as a string. Start that way. Could use an array. I tend to avoid arrays. But strings are nice because they're easy to test against and they're easy to view. So roll 5 dice. Now the problem is, so going back to here, what should it do? Well, it should roll 5 dice. But what does that mean? And so immediately we run into a fairly typical problem, certainly in games, is randomization. So I could roll 5 dice, and we'll see that how am I going to control the randomization? But let's ignore that for a while. Yes, so Cucumber software. Cucumber was one of the original names, and then they sort of abstracted the syntax to gherkin, and gherkin is very pickle-like. So yeah, So roll 5 dice results in 1, 2, 3, 4, 5. Right. So what we want to do is we want to, and you might say, well, how do you know it's 1, 2, 3, 4, 5? Well, because that's what I'm saying I want. I want it to give me 1, 2, 3, 4, 5. So, and the reason why is there's so many different places we could start from. You got to pick something, and this will help us start to flesh out what objects and what methods on those objects do we need. So let's say we want some object called Yacht, and we'll new it up. And then we'll want to do something with it, but immediately I want to get it to compile. So we'll put it there. It's there. Now it exists. And so now I can instantiate it. Right. One thing I do is again, and this comes from BDD language, behavior-driven development language. There's the given, when, and then the assertion part is then. Some people call this arrange, act, assert. I don't like that because the acronym is not helpful. And I do like the given, when, then. So given the Yacht game, when we roll the dice, they'll say Yacht, roll dice. And again, I'll immediately get that to compile. Oops. Row new. Thought I had a. Hold on, I gotta go look at my live templates. Thought I had one for that. Where oh, it must have been for the other. All right, I'll create that in a bit. So notice that I'm doing this because I want to make sure that it becomes really obvious that we haven't implemented anything yet. Yes, I did. I created a live template for this, and it was, I think it was in the EAP version, and it didn't carry, and it's not in this one. So I'll build it later. Doesn't take that long, right? So the idea is, given a Yacht, when we roll the dice, then we expect the result, and we'll have to figure out where the result come from, is equal to 1, 2, 3, 4, 5. So we need to figure out where result comes. Well, okay, so result is going to have to come from this. And we'll need to say, so that's a string. And so now we'll basically make this return a string. So we now have a test. Right? And so we are here. We wrote the test. It failed to compile. We fixed that pretty immediately. We wrote the least amount of code to get it to compile. It does indeed compile. And now we get to predict how it will fail. Well, it's going to fail with an unsupported operation exception because we literally throw that. But again, we do this and we run it this way because we want to make sure, it's clear at this stage. Well, of course it's going to throw an unsupported operation exception because we've got, what, 3 lines of code or 1 line of code, depending on how you count it. But when you've got 300 lines or 3,000 lines or 30,000 lines, it's no longer obvious. And so it feels, and this is sort of the difficulty of teaching this in sort of a greenfield project, is stuff that seems so obvious at the beginning. When you're actually in the thick of it with real code, it's not so obvious, right? And if you've watched any of my streams where we're doing that, sometimes the test fails not as expected, or in some cases passes unexpectedly, because we made an assumption that turned out to be wrong, or there was some piece of code that was doing something that we just weren't aware of. So the next step is we run this. We predict it's going to throw an unsupported operation exception, and it does. Now you may say, well, yes, again, of course it did. But sometimes I've forgotten to do this part, right? And end up with, something, or sometimes even other cases where you forget to do something in the test and it passes. So this helps us make sure that our test works, because our test is code too. And we're not always guaranteed of writing that correctly either. And so we do these validations along the way to make sure the test is working properly itself. So now what we want to do is we want to get the test to pass, right? So it failed as expected, right? Fails in the predicted way. And now we want to write the least amount of code to get it to pass. So what is the least amount of code to get this to pass? Well, the easiest way to get this to pass is that. Now, you might be saying, or you might be thinking, that's ridiculous. That's not rolling dice. Well, yeah, true. But this does tell us that, at least in this case, the test passes because it does what we expect it to do. Now, this is something that some folks call triangulation. It's like, well, okay, we've got a point solution, right? For this specific test, this works. We could ship it. If that's all we had to do, right? If every time we roll the dice, it's 1, 2, 3, 4, 5, we're done. Of course, that's not the case. So what we do is we write another test. And so this is one of the rules that we talk about in TDD. I actually didn't talk about the rules, but rule number 1 is never write production feature code without a failing test. And it's not only never write, it's also never write or change. So if you want to change something like, oh, I don't like the color that this thing is displayed in, you don't go in and immediately just change it from, red to yellow. You go and write a test or change a test that was asserting that color. The test fails, then you go change the code. So you never write or change production code without a failing test. Number 1 rule, right? In fact, those are the top 5 rules of TDD, is never change or write code without a failing test. Rule number 2 is, let's see, which one would I say is number 2? Basically, write the absolute tiniest amount of code to get the test to pass. Tiniest, easiest, straightforwardest, I know that's not a word, but that's the word I use, right? You want to write the simplest possible code to get the test to pass. It is so easy. And I do it too. It's so easy for us to write more code than's needed to get the thing to pass. What I love about test-driven development, doing the test first, is if the test passes, I'm done. I don't have to do any more thinking about about the code anymore. I'm now thinking about what's the next test. All right. So the next test, I mean, we could, do a bunch of different tests where, roll 5 dice results in various things. But what we want are tests that help us triangulate and figure out where the code is gonna end up being. Right? What the code eventually is gonna become. And what this is tests are examples. Tests are concrete examples, right? Or specifications in some cases. And when we have sufficient number of examples, we can abstract, right? And this is how we learn, right? I've been on talking with folks and on Twitter about how do we learn? How do we as humans learn? We learn through concrete examples. Concrete example after concrete example after concrete example, right? This is how, when you were a toddler, how you learn to tell the difference between a dog and a cat, right? Cat, cat, cat. You've shown a bunch of pictures of cats, and maybe not explicitly shown a bunch of pictures of cats, but you were shown, pictures of cats and pictures of dogs and pictures of, cows. And if you had one of those games, you knew what the sounds they made were, right? And you associated those concrete examples with the generic class of cat, dog, etc. Then you might have had to differentiate between cats and tigers, right? But we start with these concrete examples, and tests are the same way. We start with very concrete examples, and all our tests are concrete examples, and our code is the thing that gets more generic. As we add more examples, the code has to handle that, and it has to handle it in a nice way. So Striker says, I love rule number 2. People go nuts when I show them what it really means. Yes, yeah. Rule number 1 is too strict. It disallows refactoring. When you are adding or modifying production or feature code, this rule applies. If you are refactoring, you are in a different stage, and a different set of rules apply. The number 1 of which is you should be in green as much as possible. So this is modifier changing externally visible behavior versus changing internal structure without affecting internal behavior. So this is part of the red-green part of the cycle, which I'm focusing on here. But you're right, there is the refactoring portion where now you're in green and you need to stay in green. Oh, hydrate. Exactly. Collecting that information about what is it they're actually wanting the thing to do, that's the hard part. And so there are books on this: specification by example, example-driven development, acceptance test-driven development, BDD. All of these things are about, can you give me an example? So there's even fitness, which is based on Ward Cunningham's old fixture testing, where your examples were in a spreadsheet. So that way business people would have a very easy time of saying, well, if we make these transactions, we expect this result. You now have concrete examples. Then you can start asking about, well, what happens if they don't have enough money? What happens if they have, all sorts of, you start having a discussion and a conversation. And this is where people get into trouble. And this is a whole other topic. But I do want to mention is that getting that information, you can either get as some pre-written requirements that are pages long and open to interpretation, or you can have conversations with people. And so the whole thing about Agile talks about things like user stories written on a card are these tokens for conversation. They don't have all the information you need on that card, but they remind you of what this thing is about. Striker says it's so much more fun to just dig into the code. Absolutely, yes. Though to Attitude says, in my own app, I just use the app I built for the thing I do, and I didn't even use the poker app as I intended, and I built it. It seems contrived until you try and do really complicated businessy stuff with it, like validating a customer credit application. Yeah. Yep. You got to get examples. You have to have concrete examples. If they can't give you a concrete example, then they don't understand it enough. And if they don't understand it enough to give you a concrete example, how could you possibly write code for that? Now, I'm not saying that's not done all the time, but it seems kind of ridiculous that if you can't get a concrete example of, well, in this case, it causes a $25 charge against your account because you overdrafted. And if you can't get a specific concrete example of how that happens and what the edge cases are, you basically should say, I can't write that code until you give me those examples. All right, so what we really want is we want 5 random numbers. So I'm going to switch gears here and say, well, what we want is some set of numbers that are based on some sequence. Eventually that sequence will be random. Yes, if count as jitter dead, apply overdraft charge of 25. Just on a daily basis, right? Yes, and if you get 3 of them to give you 3 conflicting examples, and then you realize, okay, well, we need to resolve these conflicts. Which way should we resolve it? And then this is where you start getting into, the legacy business process of, well, for these older customers who are flagged with legacy, or VIP, they get this special treatment if they had their account open before 1970, right? And you get into all sorts of crazy stuff. But at least if you have the concrete examples, you can write a test for it. Right? I can write a test. This account was created before 1970 and has these attributes, and it should get these kinds of things. And now you have a people problem. Yeah, and what's nice though is if you get these examples written down concretely, not hand wavy, right? Specific numbers, specific text, specific strings. Then you can show them and say, look, you gave me these 2, right? This one and this one. One of these is wrong. How do we resolve it? But if you sometimes if you sort of talk, vaguely or hand wavy, or say, well, if it's less than some amount, and right, the more specific you can get, the earlier you can resolve those conflicts. And then once that's resolved, you can now go write tests. So while we could spend a bunch of time on sort of the rolling the 5 dice, I want to get to the scoring part. But I do want to show like what we would do to take care of the situation of how do you deal with randomness. So roll 5 dice results in IntelliJ. Why are you freezing? This is nice. And this is why I don't have streaming on my Mac anymore. What is going on? All right, while I wait, because I don't know what's going on. Something is using up all my CPU. Of course, Chrome. I'll blame Chrome. Yeah, I have no idea what that was. Okay. So what we want to do is what is going on? So Vivek said, do we set a seed? We actually don't. While we could, that's one way to do it. I have no idea what is using up my CPU. So hold on. I don't think it's IntelliJ's fault here. No, it is. Wow. What is going on with IntelliJ? It's now using 615% of my CPU. All right, I'm gonna have to kill it. That's so weird that I'm not using the EAP. That was happening with the EAP. Let's kill it and start it again. Let's run that one. Time to debug IntelliJ. No, I'm not debugging IntelliJ. Or check that the return value is the right length and number is in the right range. So there are a bunch of things we can do, but the best technique that I'm aware of is we basically provide a test double. Exactly right, Senator Gearing. Because often no one has ever been forced to sit down and think about what they do and why, and thrash out the fact that everyone understands and interprets things that they're meant to do is different. Yep. All right. Let's go back to here. Great. So I guess we got some plugin updates. So what we want to do is, so given our yacht, and we roll the dice, so we can certainly do that, something like has size of 5, right? That they're five long. But what we really want to do is we want to be able to predict that. So right now, so we could implement this by basically, whoops. From 0 to 4, and then get a random somewhere. Make this private final. Can't spell final apparently. And then do random dot next int. Give it a boundary. And I always forget whether the boundary is the upper level -1. Between 0 inclusive and the specified value exclusive. So it would help if I actually, so exclusive, so 6, but then we actually want +1. I have no idea. Let's do this. Result plus equal string dot value of. And then we'll create a string here. No, I don't care about that. And then we return it. So I have no idea what I'm doing here. I could do this. And so then if I run this test, it'll work, but now it's unpredictable. Oh, heck, I can't even do a for loop correctly. See, this is why we do small steps. 0 to, less than 4. But that was less than or equal to 4. Now we should get 5. But we'll have no idea. Well, so this passed, but we have no idea of anything about the predictability. And we may certainly want that. And so this isn't going to work. Right? So this is totally bogus. So we're going to go and back to return 1, 2, 3, 4, 5, which technically passes both tests. And it would help if I had a semicolon there. Maybe I should have rebooted my computer today because this is totally frozen. So yes, so we're starting TDD from scratch, and IntelliJ is not happy. Wow. I actually think it's Chrome that's causing problems, but So if we go back to our, go back to our tests and we ran all of them, both would pass. But we want to be able to assert something here, right? We want to be able to assert, like, this isn't going to help us, but we want to be able to assert that we're getting random, we're getting different numbers. And so what we want to do is we're going to need to, right? So we could use random, but the problem is that we have no easy way to control random. Oh, thanks for the caffeinate. Yeah, Chrome doesn't usually cause problems like this, but I can see it's using up a lot of memory. I've got some things open. So we could use a regular expression, but I want to, but let's take a step back. What are we doing? Right, we want a repeated value of something, and that something is a random number between 1 and 6. So what we really want is something that generates these dice rolls. So this is when we say, okay, there's actually a smaller object that we want to have around that is responsible for rolling the dice. So let's create a new test, which is die test. And so what we want is roll results in number between 1 and 6. Right? So now Edge. I do not have Edge installed on this. I've got too many anyway. So we can say die roller dot new var, go create it. It's in my source directory. No, it didn't. So I've run into the same problem again that and I didn't notice this. Let's go move it to the same problem, and I filed an issue. I've not seen any results on it. Is that it puts it in, unless you're really careful and looking out for it, it puts it in the same test root directory. But those are actually production code. Yeah, okay, that's better. So what we want is so given our die roller, when we roll a die, and now we can say, do we want it to return an int or a string? Let's say it's an int. And we're going to throw a new unsupported operation exception. Then we can assert that roll is between. Now, what does strictly between mean? I forget the difference. I don't seem to have the documentation downloaded. Okay, so is between. So strictly between is exclusive, in between is inclusive. Okay. I wish they would have called it inclusive. Is between 1 and 6. So if we run this, obviously it won't work. It'll throw an exception. Right, and so now we can go fix that. And here we can use the random. Random, new random. And then we can return random dot next int 6. We can run this. Now, we don't need to test the random number generator, but we are possibly using the next int wrong. And yes, I did jump ahead, and I wrote possibly more code than I needed to. Normally, I would do that and be pedantic about that. But I'm also using my judgment that I don't need to do that. So there's very, very strict TDD, but TDD doesn't mean ignore your judgment. So here I'm fine with jumping straight to this. The problem is that am I using this correctly? And so it's basically between 0 and the specified value. So if I ran the sufficient number of times, then I would find that I'm actually getting a 0. With JUnit 5, I could run this a bunch of times and see we've got a failure. And so now I know I'm using it incorrectly. So what we want is this +1. So now we've got a die roller, and if I wanted to, be really concerned about the statistical validity of the random number generator, I might write a test for that, but I'm really not that concerned. So what we've done is we've jumped from testing the outer part of the thing through the Yacht class to a thing that's responsible for rolling dice. Now I could have pulled this into I could have made this part of Yacht itself, and what I would have found is I probably would have ended up refactoring it. But the problem we were trying to solve was in this test, which is I want to have a way of predicting the outcome. Right? I want to basically provide a way that I can predict what dice are going to be rolled. So if I do the roll dice, what I want to do is and this is where the fancy dependency injection comes in, but I want to, when you're testing something, one of the important parts of tests is that they're isolated. And not just isolated from other tests, but the thing that's under test is now isolated so that you're focused on what am I actually testing here. What I'm testing here is that if I roll it 5 times, I will get 5 different numbers. They'll be concatenated together in a string, and I'll get that string. And that I'm now pretty sure that the random number generator is working, and that I'm using it correctly. And so now I can build on something that I know works, and now use it as part of an outer layer, right? So I'm fixing my collaborator. So if we were to draw a CRC card, we would say that Yacht uses a dice roller. And then now that we have this relationship, I can provide a different dice roller that is more predictable. And so that's what we're going for here, is I want to be able, so I am not a dogma person. And so, because I find for me, as you become better at some of these things, you are building up judgment, and to me it makes no sense to ignore that judgment. But different people do it differently. So what I want is to provide Yacht with something that generates a sequence. Right, that's what we're really doing. Right, there's this infinite sequence of dice rolls that we want to be able to tap into, but it doesn't have to be random. It can be predictable. And so what we can do is we can have roll dice rely on that. So we could start saying, well, we don't want one of these. We want a die roller. And so we can instantiate this in here. And then we can say, well, for I is from 0 to less than or equal to 6. Sorry, 5. Well, let's say it was 6. Let's say I made a mistake. And I said result plus equals die roller dot roll. and then we wrap that, not the whole thing, in a string value of. Well, actually, judgment does not mean thinking. In the way I think of, the way I look at judgment is its experience and its pattern matching. And so it's like, I've seen this before, I know how it works, right? If I build a shed, the same shed 100 times, I've built patterns against how that works, and that's actually doesn't require thinking. For novices, though, definitely requires thinking, and then I want them to go with that. Technically, it's a die roller because it's rolling one die. I won't get into the pedantics of that. So we'll create our result. We'll do that, and we'll return result. I have no idea if I've tied these things together correctly, but I know I've got tests, and now I can run all the tests. And so, well, first of all, I've rolled the wrong number of dice, right? Because I accidentally put 6 here, but I have tests that tell me that that's wrong. So I know that needs to be 5. So now I expect only one test to fail, the one that was predicting 1, 2, 3, 4, 5, right? Because now we're getting a set of random values. So now I can go look at this test and saying, is this test valid anymore? I'd like it to be. And so what I want to do is I want to be able to control the sequence that's getting generated. So, and yes, it would be possible to get 1, 2, 3, 4, 5. That is possible. I don't know what we could calculate the odds, but certainly that would define a flaky test. So where is the die class? There is no die class, not yet. That might happen during a refactoring. I might create a value object, but I do sense a bit of trolling there. So what we want is predictability here, because I want 1, 2, 3, 4, 5. I want to be able to control this thing in a way that provides predictable values, right? So the way I think about it is there's a lot of moving parts when you're working with code, right? There's lots of moving parts. And the idea of a test is sort of pin down all the other things, all of its dependencies and collaborators, so that the thing that's moving is the thing you're testing, right? Because that's what you want. It's like, I don't want this other stuff to move. I want it to stay in one place so it's predictable. I need to be able to predict the outcome, and I need to be able to write this test. So what I want is I want to inject something that I have control over. And so what I'd like is to inject something that provides dice rolls or die rolls, right? And that's this thing. So right now, because this is instantiated inside of Yacht, it's not controllable from the outside. And in general, this is bad. Having objects that instantiate their own collaborators leads to code that's harder to test. And it's certainly possible I might have them as value objects, and basically they're immutable. I'd probably use the flyweight pattern, and so there are only 6 of them, and so I'm basically just having references to existing instances of those dice. That might be appropriate if I were to have a graphical display, and then I only need one sort of shape object per die roll, per die value. So you laugh, but it can happen. So what we want to do is we want to inject this. We want to be able to have this set differently depending on whether we're running a test or not. Now, James Shore talks about basically nullable infrastructure. I hope I'm using the term right. I really need to watch his stuff more. And so we could sort of bake into this class the fact that if I call a constructor a certain way, I will get the one that has the predictable values. But I'm going to go sort of more the traditional way with the test double. So if I want to be able to substitute this thing, right? So the first thing I have to do is basically instantiate it in a constructor so it can be injected. And so now if we go back to our test, we'll see, well, I need to pass in this die roller thing. Well, I don't want to pass in a die roller. Can I just pass in like the values that it can choose from? Or maybe even the values that it should return. Oops. Let's go. So in order to provide a different implementation, we would have to pull an interface out. And so this is a fairly common sort of set of refactorings that I do. Oops. No, Control T, please. Which is basically extract interface. So the interface is going to be die roller. We're going to rename the original class and use interface. So we're going to have rename implementation class to random die roller. And that's the and if you've watched this stream at all, you know we don't like impl. Right? So we've got an interface that we've now defined. So we've done a refactoring, an automated refactoring, so it's pretty safe. We can run our test again. We'll see that that test still fit. Well, now we have the compile error, so we'll have to fix that. So that'll be the next thing we fix. But we'll see that die roller has an interface, one method in it, and random die roller, which is an implementation of it. It's the implementation of die roller that includes randomness. And so random die roller is a totally valid and what I would consider a pretty reasonably named implementation. We don't like impl because impl provides no information about how the thing is implemented. And yes, I broke a rule of I didn't realize that this didn't compile. So we could fix this pretty quickly with new. We want to be, let's see. So we at least have compiled. We still have one failing test, but what we're trying to do now is fix this test. So we'll go and re-extract the interface. And the implementation, since we said before it uses random, we do that. So now we see that, well, of course this isn't going to pass because we're using the random die roller. So what we'd like to do is create a die roller that provides a predictable sequence. Random die roller and random die roller impl. Ha ha ha. I would never prefer anything that has impl because it provides no information. At worst, if you can't think of a good name because maybe there's no variations that make sense or there's no description that makes sense, at least use the word default. So that shows that this is the one that would be used unless you have, you know, some other need. So what we can do is we can actually use a lambda here that basically return 1. Can we do that? Let's do it the old-fashioned way. So we want to have an implementation of a die roller that, well, we can say returns 0. We can convert this into a lambda. That's what I wanted. Oh, it returns an int. That's why it wasn't working. So this at least will give us predictable 0, 0, 0. So at least it's predictable. But maybe we want a way to provide a predictable sequence, not just always the same value. And so for that, we might have to provide a bit more of an implementation. So we can say private final private int die equals 0. And then we can say return die plus plus die. So I think that should make it pass. And it does. Now, I probably wouldn't leave this here, but if I was only going to use it once, I might be fine with having this embedded. Because the nice thing is, you know, you might have to decipher this a little bit, but it's pretty clear what you're setting up here and that you expect this to be the result. Whereas here, I just wanted to use the random die roller. I don't actually care what the values are. Now, so there was a question about weighted. So let's say you want to sort of cheat and have the dice weighted. Since this has a one method interface, I would just have a separate implementation. Unless somehow it relied on the random die roller in some weird way. Because if we look at the random die roller, right, it's literally one line of code. And if I had to rely on this, I might move this code elsewhere. And then collaborate with it differently. I'm not sure why you're saying that the die roller doesn't implement the interface properly. Totally implements the interface properly. Okay, so that's kind of the all I want to deal with in terms of the rolling the dice. No, it won't. It will never return 7 in this test. And I actually have no, this will never return 7. So that's pretty much whenever there's something that's out of control, like a random number generator, what you want to do is you want to pull it out behind an interface that you can then replace with something that is predictable in the contents or context of your test, right? And so we've pulled the behavior of die roller out into something that within the context of this test is fully predictable. Right, so you take the stuff that varies, which is the thing you want to test, and the thing that you want to test is the thing that will sort of use its typical code path, and everything else, as much as possible, you want to have fixed inputs, because the idea is you want to be able to have predictable output. All right, so that takes care of sort of the rolling of the dice, and we can do other stuff. This test assumes that roll dice returns rolls in the order they were made. Absolutely. I've got tests that do that. And that would become obvious. The rolls may be sorted, and if they were going to be sorted, then that would be another test. And I would have a test that would show that they're sorted from lowest to highest. And then this might break, and I would have to, although this test would probably be the one I replace if we're going to sort it, because it's the one that controls the sequence of the dice roll. All right. So what I want to get into with the limited time we have available, I might go a little bit longer, is basically the scoring. So what I want to do is figure out how the scoring works. So let's start with the category of ones. That's fairly straightforward. And so the question is what are we going to be, so far we were concerned with, like, just give me a string. I don't know if this string is the best way to return this, because right now I have no tests that tell me anything different. And so I kind of defaulted to string because it's kind of easy to start with. But we may find that that doesn't work when we get to scoring. And so this assumption about how the result gets returned is a design decision. And if you don't have enough information, you may find that you made a mistake. We may find we'll have to change this. And so I often hear that people get sort of upset about oh my gosh, when I was doing TDD, every time I made a change, I had to change a whole bunch of tests. And that happens sometimes. But it shouldn't be happening a lot. Okay, so all our tests are passing. What we want to do next is we want to score basically all ones, the ones category based on some role. So I'm going to put this in a different test. This was really the Yacht die roll test. And I'm going to create a new test. That's the Yacht scoring test. And so I'm going to want to test roll of 2, 3, 4, 5, 5 or 2, 3, 4, 5, 6 results in score of 0 for ones category. And so in the name of the method, and I do this all the time, is baked almost all the information around sort of the given when then that you usually want to have in your test, right? So sort of given a roll of 2, 3, 4, 5, 6, when we score it, we should get a score of 0 for the ones category. I have no idea what you're talking about, Stragger. So what we want is we want to be able to, given a specific concrete role, we want to be able to score to get the score. So we'll create a yacht. And so it's annoying that we have to pass in a die roller. And so this is where I would say, you know what, it's time to have a constructor that if we don't pass in a specific die roller, let's use the random one. Because in the normal, we could say that that's something we want to have. But I'm not quite sure I want to do that yet, because I really don't have any tests that tells me I need that. But it is something that you sometimes want to have. So for now, we're going to use the random one, because I don't know what I'm doing yet. And now I basically want to roll dice, and then I wanted to ask it, hey, what's the score? Well, one thing we know about scoring is you can't just say what is the score. As part of the game, there's a choice that's made of which category do you want this roll to go into. Right? So we are specifically saying we want the one, basically score this roll against the ones category. And so here we're taking a little bit of an outside-in thinking, saying, okay, the player hits the button to roll, it rolls the dice, and then displays them, and then the player decides, oh, please score this under category ones. So what we want is to score something, probably the result that we should have saved from here. And we want to score as ones. So let's create this method. And we'll throw a new unsupported operation exception. I'm going to go create a live template because that was the third or fourth time I did that. So we'll create a live template. And sup, throw new unsupported. Oh, heck. That. And reformat according to style. Okay. Nope. Darn it. Really? What the heck did I just do it as? It is unsup. Oh, I didn't define my context. So this would be an expression or statement, not an expression. It might be an expression. Okay. There we go. All right. Now I'm happy. Hey, Makobo. No, today we're doing, we did not wrap up the blackjack. We are basically doing a TDD from scratch of this basically dice rolling game called Yahtzee or Yacht. And so score equals this, so we'll change it so that it returns an int. And then we assert that score. So the score based on we don't know, so this should now confuse us. We don't know what to assert because we don't know what dice roll we're going to get. So we might say, okay, we need a more predictable dice roller. We could do the anonymous sort of lambda implementation kind of thing again. But we said that it's going to be 2, 3, 4, 5, 6. So let's create a class that what's the word? This is a stub. So stub die roller implements die roller. And so let's implement the method. And what we'll do is we'll create a private int array of roles, and we'll make that final. And that is a constructor parameter. Then we'll need to have some index into that. That's kind of annoying. There might be another way to do this that's more convenient, but we'll just go with this. So which role we're at, and we start at 0. And so we're pretty much going to return roles, role plus. And I don't write tests for this because I'm going to use it as part of a test. And so if I wanted to, if I felt this was more complex, I might write a test against this. So now we can do, yeah, I guess I could use an iterator. That might be nicer. Yeah, let's do that. So iterator, the iterator or iterator bowl. So rarely use that. That'll be roles. And then let's delete this constructor, delete that, and delete that. Yeah, constructor parameter. We don't want to pass in that because that's inconvenient. So we'll pass in a list of integer. And then it's that. And then this would just be roles dot next. And we should return that. Yeah, that's much nicer. Thank you. So now what we can do is we can say new stub die roller. And we can pass in a list of, so what do we say? 2, 3, 4, 5, 6. So stub is a test double, right? And it's a type of test double where we're saying, return these, return this. We're not faking any implementation. We're not, some people call this mock, but more specifically, it's a stub. Hey there, FatMaxApp. So let's now assert that the score, well, the score should be 0. Right, because we're scoring in the ones category. We've got no ones, so we should get 0. Vax, why use a double? Why not just set role in the test instead of calling a method? I'm not sure what you meant by double, but we're using this die roller because Yacht we've already had tests where it basically gets the next die roll from whatever die roller is passed in. Oh yeah, this is the JetBrains Mono. Standard font now on JetBrains stuff and Mac. Yep. So let's run this. We're running all tests. And so in general, when I'm doing TDD, as much as possible, I want to be running all the tests all the time. And that's why if you want to do tiny step TDD, your tests have to run fast. They can't take 30 seconds to run. And so sometimes if I'm in a code base where I can't run all the tests quickly, I'll take some subset and run those. Or sometimes I'll maybe just run one test class. But it's very dangerous because you may think you're going along just fine, and then you run all your tests and you realize you've broken something else and you don't know when you did it. And so by running all the tests all the time, you immediately find out when something failed. And so that's another important aspect of TDD, is especially when you're taking small steps, is that when something goes wrong, you don't have to look through hours and hours of code that you've written to figure out what went wrong. It's most likely the thing you just changed. And so it basically collapses or shrinks your search area for trying to figure out what went wrong. Now you only have to look at maybe a couple of lines of code instead of possibly 50 or 100 lines of code, possibly spread throughout half a dozen classes. So you want to be running all the tests as much as possible. If you can, run them all the time, anytime you're running your tests. Vivex, pass in a string. I could do that, but I've already set up the interface. I could create the stub die roller to accept a string. But then I would have had to parse the string, and this is just easier. Hey, Gregarious, should the team mandate a max time limit for the test suite? For unit tests, yes, it should be less than 2 seconds. Anything more than 2, maybe 3 seconds, you should go and work on that to get that back down under 2 or 3 seconds. Because it's very easy to go from 2 seconds to 3 seconds to 5 seconds, to 7 seconds, to 10 seconds. And now, and I've seen this happen over and over again. And you turn around and now tests take 2 minutes. Nobody's gonna, and I've done test first development with 2-minute long test suites. It's not fun. You gotta get your tests to run faster. There's something that's slowing them down. Either you're trying to do things that maybe aren't unit tests, which I'm not going to talk about today, or there's something else going on that's slowing them down. There's no reason micro tests that are running in memory against other objects or other things in memory, why they should take any time at all. In score, yacht score is 1. Oh, pass this in. Oh yeah, I guess I could have done that. That's true. Yeah, that's a good question. Yeah, so this was actually possibly not necessary. What I was thinking of is I was thinking sort of the outside-in approach, right? The roll the dice and then you score as ones. But yeah, absolutely, there's no reason why we should do this. So let's go and delete that. And sometimes folks are afraid of deleting code, but we're not going to do that. So what we pass in here doesn't matter. So we can just pass in the random one because we're not using it as part of this test. So yeah, absolutely, we could just pass in 2, 3, 4, 5, 6. And this is why pair programming is useful. Because sometimes people notice things that you don't. Yeah, I mean, unless you're using like a MacBook Air from 2010, There's no reason your test shouldn't run quickly. Okay, so we can run this. It's still going to fail because we've got the unsupported operation exception. And so now we can implement something. So following our rule, the simplest possible thing we could do is return 0, and that will make the test pass. And so now what we can do is we can say, okay, well, a roll of 1, 2, 3, 4, 5 results in score of 1 for 1's category. And so we can do the same thing, right? Create our yacht. Now, some folks will say, hey, why don't you put this into a setup method? Right? I've got duplicate code. To me, test code is different from production code, in that test code are examples. Right? We talked about that earlier. Tests are basically examples. So your purpose in keeping your test code in good shape is not to be really worried about duplication. I want to be able to look at an individual test, jump right into this test, and pretty much see all that I need to see, that I need to know in that test. If I have to go look at a setup method, because, hey, what's going on here? Where'd this yacht variable come from? Oh, wait, it was set up in the setup method. That's extra work, and I don't want to do that. And I'm not worried about duplication in my test code. So tests, I'm fine with keeping wet and not dry. So dry is don't repeat yourself. Wet is has various other things, but writing effective tests is one thing. So I don't care about duplication as much. If this was a complex setup, I might extract this into a method, but I don't like sort of unnamed, sort of magical things being called. Specimen, do I have a recommended framework for microservices? I like Spring Boot with Spring Cloud. There are other ones, but that's what I like. Okay, I'm not going to worry about the chat in terms of the CI. You folks are taking care of yourself there. So what we want now is we want int score equals yacht, score was 1s, and here we wanted 1, 2, 3, 4, 5. And here we can assert that the score is, well, here it's going to be equal to 1. So clearly both of these tests can't pass. And so yes, this one fails. So the way we fix this test is we return 1. Right? That'll fix it. Except now we've broken our other test. And so this is where we get into what's called triangulation, right? We have these two things that we can't, in sort of returning a hard-coded value, we can't make both tests pass. So now we have to do something else. So now we can say, well, we can say roll dot contains 1. Then we return 1, otherwise return 0. To do that, that'll make the test pass. Right? I mean, this is kind of ridiculous, but sure, it works. And so now we probably need another test. Can we do parameterized tests in Java? Yes. So with Java, with JUnit 5, we could do parameterized tests. It's not terribly annoying for sort of simple parameterization, but I'm just going to manually parameterize it. So let's say a roll of all 1s or 5 1s, 1, 2, 3, 4, 5, results in score of, actually let's do 4 1s, because there is a rule, or is that a different rule? It's basically the sum of the dice with the number 1. Oh, I thought there was some rule where if you got all Oh, you probably put that in 4 of a kind. Okay, so never mind. Let's do that. Relative score of 5 for one's category. So we expect this to be equal to 5 for this being 1, 2, 3, 4, 5. And if we run all the tests, we will see now this one fails. Right, and so this code, while it kind of worked for the first example, it clearly doesn't work for the other ones. So now we got to find some other way to solve this. I'm not going to, so about null as a parameter, I'm not going to worry about sort of validation. This is where I'm not thrilled with passing in a string. I might want to pass in a more structured or basically an object that represents the role. But we've been using string because it's been easy. So to score these as ones, roll. Let's see. We could roll stream split. No, but we could take a string and turn it into a stream. We could get cars or cars, however you pronounce it. How do you cars is usually the way I pronounce it. Well, we could. Oh, because it's not a character sequence. This is a character sequence. And then can we then do a stream? No. So we could do this the hard way. For I equals int 0 to roll dot length. And then if roll dot boy, this really feels. Was this range end index? So I plus 1 equals 1. Score plus plus. And let's move this out. And then return score. I don't know why it thinks that's a redundant substring call. Let's see. So one thing that I'm not sure why IntelliJ thinks this is redundant. I wrote that code without thinking too hard. And if I didn't have tests, I might be doing a lot more work in my head by running through this, like, okay, substring, if I is 0, then I get this character. And then if I is 1, and does that work? Right, so without tests, I would do a lot more thinking for something as complicated as this. This is kind of complicated. But because I have tests that, and maybe if I feel like I'm not quite covered enough, maybe I might write one more test, because maybe I write one that has ones at the end. But I think I've got it covered pretty well. And so I don't have to look at the code anymore. Yeah, I already did the hard coded return value. So now I've triangulated, so I've got enough tests to give me the real thing. And so we would continue down this road. And so what we haven't done is we haven't looked at refactoring. So that's an important part. And I might look at this and say, huh. And I might get to the point where this is really awkward using strings. And so a refactoring that I might want to do is say, let's not use strings anymore. Let's use like a list of ints, or maybe even an int array. Although I tend to use non-array collections. And then if we did that, what would change is the return value of this and the input value of this. Now, the other thing is, it's kind of weird to just ask the Yacht to score that's very separate from the actual scoring. And so for just the ones category, we might be okay with this, but we would probably see that with more categories, and then with the option of re-rolling things, we would see that our code structure would have to change and adapt to figure out, to adjust to those new requirements. And so sort of a background aspect of TDD is that I'm not doing a lot of design up front. I'm not doing, in this case, I did pretty much no design up front. But the idea is I don't sit down and say and plan out the entire thing. How am I gonna do this? How am I gonna handle all of the requirements of this game up front? Because none of the decisions there are, as far as I would be able to see, really architectural. So I'm not concerned about getting those correct up front. And so the refactoring being an important part of TDD is so that you keep your code basically adapted to what you've required of it. And all that's to say is like, as I get these new requirements based on the tests that I need to write, and then I look at my code and I see, huh, this is kind of awkward. Or sometimes I may not even be able to add that capability in without doing some refactoring. So right now, since all my tests pass, I don't really have much time left today. But if there's interest in continuing this for sort of another step, I could do this during the week and continue from here. Because the next thing I'd probably do is replace this string with something else. And we can look at that. We can look at that next time. Hey, brainwashed! Don't let a label tell me what to streamline. Except I set that label. No, I have. It's Father's Day, and I've got some Father's Day stuff to do. So that's why. Otherwise, I would go for another 2 hours. But we can look at this code and say, "Wow, this is really awkward." Right? It passed all our tests. Right? As far as scoring ones, that works. As far as being able to create a predictable dice rolling thing, that works too. Yeah, sorry, Luskit. But if we look at this code, to me, this is very messy code. And the reason why it's messy, besides the fact that like SonarLint is complaining about not using string builder, which I don't care about because it's only 5 iterations. But like I'm constantly there's multiple levels of messiness here. One is this has got too many levels of indentation. Like the fact that I've got an if in a for loop, that's not great. But the fact that I'm constantly converting strings to ints or looking for these things, it's just kind of all over the place. And so the next thing I would do is refactor to something other than string, because it's clear that strings are not a great representation. But what's nice is that, okay, I may have to change my tests a bit. But we would see that if we refactor this, we would be in a temporary state of things not compiling. But then once we got them compiling again, without a lot of work, we'd get our tests passing again. Thank you for the hydrate, cool wizard. So I'm going to stop here. Yes, and so Striker points out something that I would do as well, is I would basically take the thing that I wanted to do, extract this, keep this method that returns a string, and basically keep around these sort of backwards compatible things as long as possible. And then finally, when I've got more tests that use the new integer-based one, then I'd finally actually probably just delete the string-based tests. So I might have some duplication in terms of my tests. They look duplicated, but one's using strings, one's using ints. And then, but the idea is to keep not just in green, because you can, as you refactor, you might find red happens, but you want to minimize that as much as possible. And so you want to stay in green when you're refactoring as much as possible. Offie says, is it a bad idea to have a hash map where the key is the dice number and the value the number of times it comes out? Key is the dice number. That would be interesting. The contents of your hash map would be all permutations, so it would be a really big hash map. Unless you store, well, so if you're looking up the entire string in the hash map and you basically pre-cached and pre-calculated all of the possible things, that would work, although that would require a pretty big cache of things. I probably wouldn't do that. If you want to, we could to do this thing. I'm not sure how a hash map would help. It would be awkward. Except you'd have to have a hash map for each category. Because so like 11256, if you're storing the individual character. So what's ugly to me here is having to pull out the substring. So I don't really see a hash map helping there. If I could basically take this role in its entirety and look it up in the hash map, then I can get rid of all this part of the code. But if I'm still having to get the substring, that really bugs me. This code right here with the substring is really kind of messy. But there may be other ways to do it. The nice thing is once you've got the tests passing, you now have the freedom to play with other ideas. And that's something that I don't think is always taken into account when people think about TDDs. Like, oh, I'm writing all these tests. The public int scores ones, hash map integer, turn roles.get. Well, once it's in integers, then this becomes a different story, right? And so once we convert it over to integers, then we'll see how we can solve it. But I thought we were talking about hash maps in terms of the existing strings. But yeah, once we get to integers, stuff is a lot easier, and there are different ways we could do it. So that's it for today. This stream was meant to be, sort of time limited, and I hope it gave you a flavor of the TDD process. The random stuff is sometimes sort of weird, but the scoring is really, I think, where the TDD stuff hopefully is more clear. All right, thanks everyone.
Be strong.